one which deals with transfer of energy. So here we are transferring energy from one place to the other place. There are three types of thermodynamical equilibrium. There are mechanical equilibrium, thermal equilibrium, as well as chemical equilibrium. Heat is a form of energy which flows from the body at higher temperature region to a body at lower temperature region. Hello everyone, I am Rinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 1 of chapter 12, and chapter name is Thermodynamics. So in today's class, we are studying something which is associated with the physical properties like temperature, work, heat, energy, etc. So in today's class, let us see basic concepts of thermodynamics, that is introductory class of this chapter, chapter 12. So here, what is meant by thermodynamics? Thermo, it means it's something which is dealing with the temperature of what? Temperature of a system. So here we are talking about a system whose temperature either increases or decreases or remain constant. Let us see these things in the further sessions. So here we have got thermodynamics is the one which deals with transfer of energy. So here we are transferring energy from one place to the other place. So I told you already that energy is the one which can neither be created nor it can be destroyed, but only transformation can be seen. So here we are talking about thermodynamics. So thermodynamics is the one which deals with transferring of energy. That transferring of energy means from one place to the other place, from certain region to a certain region, higher region to a lower region, in that way. So what sort of energy is getting transferred over here? That is heat energy. Thermal means thermo, which is also equal to the temperature. So here temperature means heat is the basic concept of this temperature, because as you all know, temperature is a measure of hotness or coldness of the body, but heat is the one which is responsible for the temperature to occur. So it is the thing that transfer of heat energy takes place from one place to the other place, and the conversion of heat energy to mechanical work. So energy is getting converted to certain work. Okay, so it is just transferring itself. That is, the energy is getting transferred from heat energy to a mechanical work. There is no addition or deletion of any sort of energies in between. So that is all about your thermodynamics, what exactly it deals with. So here we talk about a fixed identity of mass. So that is all about your thermodynamics. So here in this thermodynamics, there are certain variables which varies. Okay, so variables are the one which varies, and what are those variables which determine the thermodynamics? So thermodynamics is determined by temperature, pressure, its change in volume, how much of heat energy is present over there, how is it converted, where it is exactly applied. These are the things we see in thermodynamics. So certain variables are there like temperature, pressure, internal energy, volume, heat energy, work. So these are the variables. These are known as variables, which we can call it as thermodynamic variables. Suppose if there is changes which given to this thermodynamic variables are the one which varies. That is why the term is given as variables. Suppose if there is certain change in thermodynamic variables, what happens? The complete process becomes a thermodynamical process. So we call that as thermodynamical process. So what happens? Changes means what are we talking about exactly? That is, we are talking about a system which is having heat energy. That means it is having certain temperature. So when the system is present in the surroundings, what happens to the object as well as the system, that is the surrounding? system and surrounding we are talking about right now. So the temperature or the heat energy within the system is getting exchanged between the surroundings as well as the system. There is an exchange which is taking place, which will directly or indirectly affect these variables, and there are few changes. So this is all about the thermodynamic concept, that is the introductory part of the thermodynamics. So actually what we are talking about, there might be loss in temperature, gain in temperature, loss in heat, internal energy, gain in internal energy, the work done may decrease or increase. So there are few changes what we will study in further sessions. So next we have got thermodynamic equilibrium. So what is there in this thermodynamical equilibrium for us to study? So here there are three types of thermodynamical equilibrium. There are mechanical equilibrium, thermal equilibrium as well as chemical equilibrium. So what is this meant by equilibrium? Thermodynamics, something which deals with the temperature or heat energies. So what is this equilibrium? Equilibrium means it is equal. So here we talk about the system as well as surroundings. When we talk about system and surroundings, the system and surroundings will have different temperatures at the initial state. The system will have some other temperature as well as the surrounding, that is, you can call it as room temperature. Surrounding will have different temperature. So we will have to check what are the temperatures. So by using thermometer, the measuring device, we'll get to know what is the temperature of system, what is the temperature of the surroundings. Then what is meant by this equilibrium? How can you get equal temperature? That is, the heat moves from higher temperature region to a lower temperature region. So when there is spreading, it is getting transferred from higher temperature region to a lower temperature region. What happens to the heat of the system and surroundings? They become nearly equal. That is, if the system is having higher and higher temperature than that of the surroundings, this temperature is lost. That is, the system loses its temperature, that is, it loses its heat. When it loses its heat, what happens to the surrounding temperature? It starts gaining heat. So until when it loses and when the surrounding gains? It is only until it acquires equal temperature. The surrounding also should possess the same temperature as that of the system is. So this is nothing but equilibrium. So now you can say the system is said to be in equilibrium. So this is all about your thermodynamic equilibrium, out of which we have got three types: mechanical equilibrium, thermal equilibrium as well as chemical equilibrium. So here mechanical equilibrium, that is, here in this equilibrium is the tendency of a system to be at rest, that is at uniform state. Okay, so here we have got mechanical, we are talking about mechanical equilibrium. So what is meant by mechanical equilibrium? In the sense, there is no unbalanced force which should act at different parts of a system. Suppose if you consider this system, there shouldn't be any unbalanced force. If there is no unbalanced force which is connected with this equilibrium, then we can say it as mechanical equilibrium. Okay, so there is no unbalanced force which is acting at different points of the system or with the system and surroundings. If you're talking about only system, then it is, there should be no unbalanced force at different parts of the system. Okay, if you're talking that the system is placed in a surroundings and we are comparing system and surroundings, then we have to say that there should be no differences between the system as well as the surroundings in the work which is done. That is the work, that is the force. Work is nothing but the force which is exerted. So the force acting on the system as well as the surroundings should be equal. Okay, so wherever at any part of the system, the force acting should be balanced and it shouldn't be unbalanced. If that is the case, then you can say that the system is in mechanical equilibrium. So that is all about the first point, that is mechanical equilibrium. Secondly, let us move to the second point, that is thermal equilibrium. So what can you find in thermal equilibrium? So when can you say thermal? Thermal is nothing but the temperature. So here when we see thermal, we'll get to know that the temperature is acting on this part, that is thermal. What is meant by equilibrium? Once again, equilibrium means it is maintained. The temperature is maintained over here. Okay, we are talking about thermal. Okay, in mechanical, it was the force which we were talking about, that is the work which is done on a system. Here in thermal equilibrium, we talk about the temperature. So what is this temperature? It is a measure of hotness or coldness. So how can you say temperature is in equilibrium? That is, the system is getting provided with the constant temperature, that is the constant heat is getting inserted on the system. Then you can say the system is in thermal equilibrium. Suppose if you consider system and surroundings, then it will be loss of heat and gain of heat by the surroundings, as I discussed earlier. So this loss as well as gain of the heat or the temperature between the two bodies, that is the two bodies which you are considering, then it attains equilibrium state. Okay, so that state comes under this thermodynamic equilibrium. So that is all about your thermal equilibrium, which deals with the temperature. Last point, that is chemical equilibrium, means again equilibrium, it is a tendency of the body to be in uniformity. So what is this chemical equilibrium here? The chemical composition of the system. So if you're considering a solid system or liquid or gaseous, any system of your choice, you know that each of the matters, that is state of matter, is made up of components. What components? It can be a chemical component. So we are talking about chemical equilibrium. So such kind of an chemical components, that is composition of a substance, that is a system, is said to be equal with the surroundings. So it has got equilibrium. So if the chemical composition present in the system has got equilibrium, then you can name it as chemical equilibrium. So that is all about your third point, that is chemical equilibrium. I hope you are clear with mechanical equilibrium, chemical equilibrium, as well as thermal equilibrium. Having these concepts, that is what is meant by thermodynamics, how the process takes place, what is the system and surroundings, what you are considering, and its variables, and the types of thermodynamic equilibrium. Let us go forward and let us further check into laws of thermodynamics. So as we all know, there is existence of laws for each and everything which happens in this universe, and these laws were given by too many other physicists. They have given their own law by observation, by practical aspects, by observing, experimentally done, and they have given certain laws. They have stated certain laws, and those laws are studied by us, and few of them modify it even now. Okay, so here in this thermodynamics, we have got 4 laws under thermodynamics, out of which let us study step by step, that is zeroth law, first law, second law, third law, fourth law, in an order. So when we study this in an order, we will get to know much more about the thermodynamic laws. So first of all, we are starting from the initial step, that is the zeroth law of thermodynamics. So what does this zeroth law of thermodynamics tell us? So let us read the statement, that is, if two systems, so here I told you, if you are considering thermodynamical system, it is a system wherein we are considering which has the axis of this temperature, internal heat energy, pressure, volume, etc. So here we are considering a system. A system over here has got its name as A and B. So here there are two systems, A and B, which are separately in thermal equilibrium. That is, system A is having separate thermal equilibrium and system B are also having separate thermal equilibrium. So here we have got system A and system B, and both the system are said to have different thermal equilibrium, that is different temperatures. Why equilibrium again? Its temperature with the surrounding is said to be equal. So system A is in equilibrium with surrounding, and system B is also in equilibrium with its own surroundings, and here with the third system C, and system C is also in equilibrium with its surroundings. So here what is the statement? System A is in equilibrium with C and B is also in equilibrium with C. Okay. Then the system A and B are in equilibrium with each other. So how can you give this? So here when we are considering about the thermal equilibrium, we go with the temperature. So here, what is our point of interest? It will be the temperature what we are talking about. So suppose if you consider system A has got its temperature given by T subscript A. Similarly, system B has got its temperature as T subscript B. Similarly, system C has got its temperature T and C. So according to statement, what do we have? We have system, that is TA, temperature of first system is equal to the third system TC. Again, temperature B, that is system B's temperature is equal to system C's temperature. System A is in thermal equilibrium with C and system B is also in thermal equilibrium with C. So what happens? It is that you have got two also common thing, that is both are also in thermal equilibrium with C. Then you can name it as TA is equal to TB. That means if system A is in thermally equilibrium with C and system B is in thermally equilibrium with system C, then system A, that is system A is in thermal equilibrium with system B. So this is all about your zeroth law of thermodynamics, a general aspect of it which you can understand very easily. So what is the point of interest over here? In what are we concentrating? It is the temperature which you are taking here in this case. So now, having the zeroth law of thermodynamics, it is just that it is in thermal equilibrium in the sense the temperature, that is the heat of the system, is in thermal equilibrium with the surroundings. Similarly goes for the second system as well as third system. So that is all about your zeroth law of thermodynamics what we study here. Next, coming on to the heat, internal energy as well as work. So what is that meant by heat? Heat is nothing but the form of energy. So can we delete heat or add heat in between? No, there is no addition or deletion. That is, there is no origin or its death. That is the deletion. It is just that the energy is neither created or it is destroyed, but it is transferred. It is just changing itself from one form to the other. That's all. But there is no addition or deletion of any sort of energy in a system. So in what sort of a system are we talking about over here? That is a system. Here in case of thermodynamics, we are talking about thermodynamical system. There are certain variables which keeps varying when the heat is supplied or heat is deleted. So let us come into this, that is heat. Heat is a form of energy which flows from the body at higher temperature region to a body at lower temperature region. That is, suppose if you boil a water, that is a vessel is present which is filled with water and there is certain fire which is given to it. So when the heat is supplied to a vessel, what happens? The vessel gets heated up first and then the water gets heated up. That is the conduction method what I'm talking about. Okay. So once the vessel gets heated and there is heating of water, what happens to the base? That is, it is the region which is having higher temperature. So how does the heat flow? How does the heat flows? It flows from higher temperature region to a lower temperature region. Lower temperature region is nothing but cold region. And how does the variation takes place? Because of the convection method. That is, the molecules keep going above and below, above and below. That is, the density keeps on changing, correct? When the density changes, the layer displaces. This is all about your heat. That is, heat is a form of energy which gets transferred from one place to the other place. That is, the higher temperature region to a lower temperature region. So there is just the movement of the heat. That is, the movement of the molecules is nothing but the heat energy, and this is responsible for the overall temperature of the body. That is, either the coldness or the hotness of a body, then that term is called as temperature. Heat is exerted to the molecules, whereas when you compare the temperature, it is for the whole body. So this is the difference between heat and temperature. Next, let us see the internal energy. So what is this internal energy? Internal energy is nothing but it is a sum of potential energy and kinetic energy, which I can give it as internal energy is the sum of potential energy and kinetic energy of the molecule. So this is all about the internal energy which is present within the system. So suppose you give a heat, that is the supply of heat to a system. Suppose if you supply heat to a system, when heat is supplied to system, what happens? Its internal energy, which is given by symbol U, starts increasing. Why does it increase? Because when the heat is supplied to a system, its molecules, that is the system's molecule, starts vibrating, which increases its temperature, that is its energy. When the energy increases, that is the potential energy as well as kinetic energy of the molecule starts increasing. That is what it is. Sum of both gives you internal energy. That means indirectly or directly it is said that internal energy is said to increase. Okay, when there is loss of heat, then you can say that the internal energy decreases inside the body. Okay, the movement of the molecule starts decreasing when the heat is very less over there. So this is all about the heat. When the heat is more, that is when the heat is gained by the system, the internal energy increases. When the heat is lost by the system, that is heat is lost here, internal energy decreases. So this is all about the internal energy which is associated with the system. So having this concept, let us study what is this work. Work is nothing but it is the energy which is transferred from one system to another by a force. So the force is responsible for the work to be done. That is work to be done on the system. There is force. Force means the work done and the displacement which is taking place by that object. When that is the case here, the energy which is transferred from one system to another system by a force which is moving its point of application in its direction of work. So here the variables are nothing but the pressure, volume are the variables of this thermodynamical system. When I had discussed heat as well as work. So out of those variable conditions, actually the pressure, volume, these are said to be the variables but not heat and work. Why not heat and work? Heat and work are said to be the modes which is responsible for this thermodynamics. So as we have seen in our previous slide, we had discussed in our introductory class, that is heat, energy as well as work, which was given at last. So this is the mode of heat transfer. So this is a mode which is responsible for this thermodynamical systems, whereas the rest of the things are said to be the variables. Now let us move to the next topic, that is the first law of thermodynamics. So what do you understand by the first law of thermodynamics? It is nothing but the heat energy which is given to a system is equal to the sum of increase in internal energy and the external work done by the system. That is, just consider heat energy. So heat energy you're giving, that is you're exerting certain heat on a system. Let the heat energy be dQ, and it is given to a system which is equal to sum of increase. Let us check increase in internal energy. So how do you give internal energy? Internal energy is given by U. But there is increase, that is the changes which is taking place, that internal energy which is given by D. So change in the internal energy, that means it is increasing. And the external work done by the system. So internal energy is over. Now external work. So this external work can be written as D and W. So we have dQ, du and dW. So these are the three concepts what we are having. So when we have this, let us read our statement again and let us come into an equation of the first law of thermodynamics, that is the heat energy given to a system. So this is given to a system which is equal to the sum of two, that is internal energy, the sum of potential as well as kinetic energy. That is, when a heat is supplied to a system, there is vibrations of the molecules which is taking place within the system. That vibration is equal to the kinetic energy as well as potential energy together. It is summing up of kinetic and potential energy. Totally it is called as internal energy. There is certain work which is done on a system. So that is what we are giving in this equation. So you can tell it as the heat energy given to a system is equal to the sum of increase, that is du, increase in the internal energy and the external work which is done. So dq is equal to du plus dw. This is the equation of first law of thermodynamics. Okay, so it is a sum of internal energy and the work is done. Suppose if you consider there is a work which is done telling that dW is equal to, when there is a work done, your pressure remains as it is, but there will be change in its volume. I'm talking about the variables in thermodynamics. So what are those variables in thermodynamics? Pressure as well as volume. Whereas heat as well as internal energies, energy work done, these are all the modes. Okay. So here we have dW is equal to P into dV, where pressure is not changing but the volume changes. So when that is the case, you can rewrite this equation as dQ is equal to du plus P into d and V. dQ is equal to du plus P into dV, where dQ is the change in heat, that is the heat energy which is supplied to a system. du is the internal energy. dW means it's a pressure with the change in volume. So this is the other equation, that is the modified equation of the first law of thermodynamics. So I hope you're clear with the zeroth law as well as the first law of thermodynamics. So in this case, we have few conditions, okay? So you have got heat energy dQ. When you consider dQ here, in dQ, that is the heat energy, when the heat energy is absorbed by the system, that is gained by the system, then you can give the heat energy to be positive. So when the system absorbs heat, the sign conventions for this first law of thermodynamics is positive when the heat is absorbed. When the heat is lost by the system, the dQ, that is the heat energy, is said to be negative. So that is all about dQ. Now let us come to dW. So when we consider dW, that the work done by the system means it is considered as positive, and work done on the system is considered to be negative. If the work is done on the system, it is negative. If the work is done by the system, then it is positive. You're clear with heat energy as well as external work. Now let us go to internal energy du. So when the temperature starts increasing, that is the heat energy is given more and more. When the temperature of the body is increased, system is increased, then the internal energy is said to be increasing, that is it is positive. When the temperature or the heat energy which is supplied to a system is very less, very small, then the temperature is said to be negative. So that is all about the internal energy, because the way the molecules inside the system vibrates, that always depends upon the heat which is given to the system. So if temperature is more, internal energy is more. If temperature is less, internal energy is less. So these are the sign conventions as well as the equation for first law of thermodynamics. So in today's class, we have studied regarding the introductory part of this thermodynamics, as well as some thermodynamic variables, what differentiated variables, as well as what are modes which are responsible for this thermodynamics. Then we studied regarding the zeroth law of thermodynamics as well as first law of thermodynamics, under which we have internal energy, heat energy, as well as work done. So what is the difference between what is meant by temperature? It's heat, internal energy, work which is done, and vibration of molecules. So these are all different concepts which are merged into one and given as thermodynamics. So let us study the details about this thermodynamics in our next session. Until then, have a good day. Thank you.